We're going to go over number 5 from the 13-2 classwork. It says to write a square root function that matches the given domain and range. So let's look at this. It says here that it has a domain from 4 to infinity. Domain has to deal with the values on the x-axis. So here's 4 on the x-axis, and when we talk about going to infinity, so from 4 to infinity, it's going to be everything from 4 and to the right. So what does that mean in terms of covering the graph? That means that wherever the graph is going to exist is everywhere where I'm shading, and to the right onward. For the range is from 0 to infinity. So then that means I'm going to go to 0 on the y-axis, and infinity means it's going to keep going up. So that means that the graph has to exist somewhere up here. Now that I've drawn in where the domain and range is, I want to look at where that overlap is. That overlap where I have the yellow and red highlighter, because that is going to tell me where my graph has to exist. Well, if it looks like a square root function, well, let's start by drawing the parent. Here's the parent function. The parent that we've graphed a couple times by now looks something along the lines of this. This is the parent graph f of x. So then I have to figure out how to move this so that it is in that region where I have that yellow and red. And so let's do that one in blue. If I move it to the right 4 units, then I have something that looks like this. And if I look at that blue graph, it is right exactly where that red and yellow overlap is. So this is a graph that works. So like I mentioned, it moved to the right 4. And there's nothing else happening. So that means I can go ahead and write the equation of my graph. Let's call this g of x. That means g of x is equal to square root of x. If it's right 4, it's going to be minus 4. And that's how we get the graph for g of x for number 5. Now for number 6, we're going to do something very similar. Again, write a square root function that matches the given domain and range. So here's our graph. It says that the domain is from -8 to infinity. So again, that is left and right. That has to deal with my x-axis. So -8, 1, 2, 3, 4, 5, 6, 7, 8. -8 is here. So if it goes from -8 to infinity, that means it's going to go here and cover everything up to that side. Let's go ahead and highlight what that would look like on the graph as well. Everything from -8 onward. Here we go. So that is what we mean when we say the domain goes from -8 to infinity. It can exist anywhere on that side of the graph. And then it also says that it has a range from -infinity to 9. So what does that look like? Well, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is probably going to be about here. And if it's from -infinity to 9, then it's going to be everything below 9 and up. So everything here. So what does that look like graphically? That means it is going to cover everything here and below. Now what I need is a graph that's going to, again, be in that overlapping red and yellow part. And maybe a good place to have a starting point is here in order for that domain and range to work. And so if I try to draw a graph that goes up, well, then it's not in the overlapping part. It's going to be in the yellow. I don't want that. If I make it go to this side, then it's not in the yellow or the red, so it doesn't fit that domain and range. If I have it exist over here, then it's only in the red. It only fits the range. It doesn't fit the domain too. So what I need is I need it to go downward like so. Let's call this one h of x. And normally our parent graph looks like this. So then let's kind of compare what would I have to do with f of x to h of x to get there. And so right away I notice, well, it's pointing in different directions. There's definitely a reflection happening. So then I can say h of x is equal to negative square root. It also looks like it moved maybe to the left 8 units, and then it also looks like it maybe also moved up 9. So then if it moved left 8, then I can write x plus 8 inside my square root. And then if it moved up 9, then I can say plus 9 outside of the square root. And there's our function, negative square root of x plus 8 plus 9.